learned and be able to learn more as we go along. And we thank you for all the many blessings that you have blessed us with. And we say these things in the name of Jesus Christ. Amen.
Amen. Thank you very much. So it's recording.
Okay.
So, let me see. Okay. So the first question: what is the sampling distribution? The sampling distribution is the set of all possible sample means from a population.
Okay.
Okay.
So who wants to?
I can read number 2.
Okay.
What is the shape of sampling distribution of the sample mean when the data are normally distributed? That would be normal.
Yes.
Yeah. So the third one, what is the shape of distribution of sample means when the data are not normally distributed, but the sample size is large? I answer approximately normal.
So how does the shape of the distribution of sample means change when sample size is increased? So the sample distribution more.
Yeah, let Drew answer.
Sorry.
Drew don't answer yet.
Oh, sorry.
He wants, right?
Sorry.
The distribution more closely approaches a normal distribution, and the standard deviation decrease of the mean is unchanged.
Mm-hmm. Okay.
Okay. What is the difference between the central limit theorem and the law of large numbers? So the central limit theorem is the sample size. If the sample size is large, the sample mean will be approximately normally distributed. While the law of large numbers means as the sample size increases, the standard deviation of sample mean will get smaller.
Right.
Next one. It's me or it's Roberto? I don't remember. When is X normally distributed? Each bar is normally distributed if the data were drawn from a normal population or if the sample size is sufficiently large.
Okay. All right. Please cut out the square of the following page, select 5 at random, and compute the sample mean X. An alternative to cutting them out is to go to random.org and generate 5 random integers between 1 and 30. Use the salaries from the 5 squares corresponding to the 5 random integers to compute the sample mean X. You will use this information to complete part 2. Okay, so number 7 says randomly select 5 of the 3 salaries and compute the mean. What is the mean of your sample?
So the mean of my sample is 48,216.
Okay.
All right, moving on then. I didn't do that part, so.
Neither do I. I only
We must select randomly 5 and do the mean for those 5.
Okay, so we're on B.
Yeah.
So the graph illustrates the distribution of sample means. There are 142,506 possible combinations of the 30 salaries. Draw 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A.
Sorry, what question are you reading? Were you reading?
7B.
7B. 7.
The graph.
Okay. Does your mean appear to be unusual? Explain why you think it is or it is not unusual. I can share mine. Oh, it's very slow. Are you seeing?
Sim, yeah.
Okay, this is my mean. This is a little bit to the right of the real mean. So I think it was supposed for us to compare our mean from yours, compare my mean from yours, and okay. So I think it's not unusual. It is?
I have no clue.
So that was your mean from the sample size, right?
Yes.
Because you chose 5 from this chart.
Sorry?
So that was what you got for a mean from the 5 that you chose from the chart,
Yes.
right?
Yes.
Okay, so I think the question's asking, oh, well, what one are we on right now?
Compare your mean from question 7a to the means obtained by at least 3 other individuals. What you notice in practice, you only get to see the means from the sample to draw. You do not get to observe any other mean that could have occurred. So, well, what this says is that if you chose randomly 5, your mean is going to be different from mine, probably.
Right.
Yeah. So if we do the mean of our means, it will be close to the mean, or very near to the mean, right here. It's the mean of the mean. It's the mean.
Right.
Okay.
So the more means that we do, it'll get closer.
Close to the mean. Yeah.
Right. But for C, it's asking, does your sample mean appear to be unusual? It's a little bit unusual because it's more to the right than
Yeah.
you would think it would be. But that's just because you used a small sample.
Yes, of 5.
Right.
Okay. Bigger the sample, more accurate is the mean. I don't know if it is well said.
Bigger the sample, the more narrow the mean is going to get. It's gonna
Yes, narrow. Yeah.
become more normal.
So number 8.
Yeah.
I can read it if you want. The Graduate Manager Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration (MBA) programs. The scores of GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample of 10 students taking the GMAT. What is the shape of the distribution of sample means for all such samples? Well, it's normally distributed because it's the mean of the means of all means.
Right.
So how do you know the distribution of sample means? How do you know that the distribution of sample mean has this shape? The parent population is normally distributed.
Okay. And then number C says, what is the mean of the sampling distribution of sample mean scores for all such samples?
It says here it's normally distributed and has a mean of 529. So the sample of the mean of the means is mean, so it's the same. So what is the standard deviation of the distribution of samples mean scores for all such samples? Standard deviation has this formula, and I check it, and it gives this. It's the
We don't see your paper, what you're saying. The questions, you must scroll,
I'm scrolling. I'm here.
but it's not appear for me. It's only appear the image and the question D, E, and 8. I don't see anymore.
I think it's something from the internet. Oh,
Yeah, I'm seeing the same thing.
Okay.
I don't know why. I'm going to share again. No. Are you seeing it?
Yeah.
So the sample deviation of sample means is this formula, and I divided 113 by the square. Well, how you say it? Square root
Square root.
Yeah.
of
Square root.
divided by square root of 10. So it gives
Uh-huh.
this. It's correct. It is.
Okay.
Okay.
All right. Do we want to move on to the test now?
Yes, I can. Let me open it. Moment. Okay.
You guys ready?
I'm opening it. Just a moment. I can share mine, but I don't know if scroll works. Okay, let's see. No, it's not here. Let's see, no, it's not here. Just a moment. Oh, it's already open.
Now,
Okay. Are you seeing it? Complete.
Yeah, I can see it.
Middle preparation. I actively participate in this. Yes. Let's go to the third one. Okay. When you are taking a sample size of n equals
Maria, you could open in the beginning the application that we have the normal probability, the applet.
Ok, Gina, fala português.
No início
I didn't
dessa
understand, she's
pergunta
going to
tens
speak
o
in
Apple para abrir.
Ah, ok.
Podes abrir já para depois fazeres mais rápido. Isso.
Okay. When calculating and okay. Okay. When you are taking a sample size of n equal to 5.
What is the shape of man?
This would be skewed to the right, wouldn't it? Because it's a small sample size and the normal
Yes.
and what it was skewed to the right.
Okay.
That wouldn't matter then. I feel like.
Okay. So when you are taking a sample size of 100, what this shape of distributions means? It's normal.
Normal.
Right, because it's a high.
Yes, it's a higher sample, more than 30. going to be normal. When you are taking a sample size of 5, what is shape of the distribution of means histogram when the parent population is normally distributed? It's normal.
I said norm. Yeah.
Wouldn't matter.
When you are taking a sample size of 100, what is the shape of the distribution of means histogram when parent population is normal? It's normal. Everyone agrees?
Yeah, I agree.
Okay. When should distribution of means be normal distribution? Wow. Let's see. Choose all correct responses. Data are drawn from a population that is normal distribution and sample size is small. This is correct. Data are drawn from a population that is normal distribution and sample size is large. Data that is and sample size is small. Data. Okay. Is that correct?
That's what I was thinking. Does anyone disagree?
No, I agree.
That's right.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normal distributed, then sample mean will follow normal distribution.
For this one, I think it's the last one. It says if the sample size is large, the shape of the distribution of the sample means will be approximately normal.
Okay, let me see what this central limit theorem says again. Sorry. If the sample size is large, the sample mean will be approximately normally distributed. Yes. Thank you.
The last one.
So it's if the sample size is large, the shape of distribution of sample means will be approximately normal. Last one.
Right.
So use the following information to answer the next 4 questions. So mean is 10, and standard deviation is 6, and the n is 36. What is mean of the population of the sample means? It's 10. Correct?
It does. It's regardless. It would stay the same, I think.
Sorry?
I think it wouldn't matter. It would just stay the same. So I'd assume it'd be 10.
Yes. So, what is the standard deviation of distribution of sample means? Let's find out.
So on this one, do we need to use that formula?
Yes.
Yes,
So, let me see the formula. I need to
So
go.
it's 6 divided by the square root of 36. I think.
So, it's, let me see again. Okay, so it's 6 divided by, yes, square root over 36. Let me.
So 1.
So 6 divided by square root of 36, it's 1. It's 1?
Yep.
Okay.
That's what I got too.
Okay. Regardless of the distribution of the population, if the sample size is large, more than 30, what would the shape distribution of the sample mean? Would be normal.
Right.
I think we have one more. What theorem will justify your response to the last question?
I said the central limit theorem.
Yes.
Last one.
Law of large numbers. But let me see the other ones just to check.
Law of large numbers has to do with the standard deviation.
Okay. Yeah.
Sorry.
If the sample size increases, the standard deviation will be smaller. Okay, that's right.
So because it had to do with the mean, I think it was the central limit theorem.
Yes, yes. Okay, I'm going to submit. Just a moment.
We need to finish the recording, no?
I'm going